Okay, well, it was my bad. This morning, we had a Native American workshop today on the Tonkawa campus, and I just didn't get to uploading the Zoom meetings. So I will get those uploaded shortly, but as promised, we're going to work a few problems today. And that's what our focus is on circuits, because circuits is usually where folks get a little bit of a challenge. So we're going to start with some simple problems. We're going to do a bunch of different ones here. So I have a battery, has an EMF of 15 volts. The terminal voltage is 11.6 volts when it is delivering 20.0 watts of power to an external load. And that external load is an external load of R. We want to know what is R. And we want to know what the internal resistance is. So let's kind of break out the problem a little bit. Basically what that's asking, so let's assume that we have, like our regular car battery, 12-volt car battery. When it's talking about the terminal voltage, it's looking at that voltage across that part. So remember what we said yesterday is that my voltage is going to equal my EMF minus the current times my internal resistance. So that's what we have and what we're going to be working with. We also are having to deal with power. So we've got power, and power can be written as voltage squared over R. So how we're going to find this initial R is we're going to use our power equation. And we're going to use this terminal voltage. So we're going to solve for R, and that's going to be my voltage divided by R. So that gives me 11.6 volts. We're going to square that. We're going to divide by, oops. Okay, let me get away with stuff. We're going to divide by power. And we said we have 20 watts of power. And if I plug that into the calculator, I'm going to get 7.3 ohms. So basically, that's going to get me that part. So now we know what my big R is. So I need to figure out what I is. I is going to equal my voltage divided by my resistance. I'm still going to use my terminal voltage because that's the voltage that I have available, divided by the R we just calculated, 6.73, and that's going to give me 1.72 amps. Once I have that, once we know what the EMF is, we can solve for little r. So let's solve for little r first. We get V plus IR is equal to my EMF. I'm going to get IR is equal to my EMF minus V, and my little r is going to be my EMF minus V divided by my current. My EMF was given to us as 15. The voltage that I have available is 11.6. The current I have figured out 1.72. I've got that in there. And now if I do that, that's going to give me that little r is approximately 1.98 ohms. So we can utilize this. Kind of brings back a few of the things that we were talking about yesterday: power, resistance, going through and working through that type of a problem. Okay. Let's stop recording real quick and start recording again.